This video will be a review of the limit definition for a derivative with tangent and normal line review as well. So let's look at the first problem. Use the definition of the derivative to find the general derivative for the function f of x. So the big thing that you have to remember is that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now the first thing that I would do is come over here and do your shorthand derivative. This will help you make sure that you are staying on track algebraically and not making any mistakes. So we now know that the derivative should be 4x minus 3. Okay? So in order to plug into this formula, I need all the pieces. So I have f of x. I need to find f of x plus h. So that's going to be 2 times x plus h, quantity squared, minus 3 times x plus h. Okay? That's going to give me 2 times x squared. Now remember, to square out a binomial, we're going to use that shortcut, square the first term, twice the product, plus the last term squared, minus 3x minus 3h, just by distribution. Okay, so I have to distribute my 2, so I'm going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h. Okay, so I'm going to take that and start plugging into my formula. So I have the limit as h approaches 0, that f of x plus h is this long thing here. So I have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus, make sure you use parentheses, the function, 2x squared minus 3x all over h. So I need to do some algebra cleanup. So I have 2x squared minus 2x squared, and I have a negative 3h minus a negative 3h, which also goes to 0. So then I have the limit as h approaches 0 of 4xh plus 2h squared minus 3h all over h. And I can reduce this all by a factor of h. So I'm going to have the limit as h approaches 0 of 4x plus 2h minus 3. Now I'm ready to plug in that 0 for h. Remember that h approaching 0 has no bearing on 4x, so the limit of a constant is the constant plus 2 times 0 minus 3, which leaves me with 4x minus 3, which, given our basic differentiation rules, we already knew that's what we should have gotten. Number 2 says to find the slope of a tangent line to the graph f of x equals x squared minus 4 at the point negative 2, 0. Okay, so that means that I'm going to find f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. So a couple things that we need to make sure that we remember, that this is the value of a. Okay, so we're talking about at negative 2. So I know that the value of f of negative 2 is already 0 without any subbing in. I need to find the value of negative 2 plus h, f of negative 2 plus h. So that's negative 2 plus h quantity squared minus 4, which gives me a positive 4 minus twice the product. So that's negative 4h. And the first term squared is h squared minus 4. So we have 4 minus 4, so we're left with negative 4h plus h squared. So again, I would probably take the second to figure out what f prime is. So f prime of x is 2x. And remember that our slope of our tangent line, which is what we're looking for, just the slope in this particular problem, is the value of the derivative at the point. So that would mean f prime of negative 2, which is exactly what we're saying, f prime of a, right? And 2 times negative 2 is negative 4. So that should be the output that I expect to get with the limit definition. So I have then the limit as h approaches 0 of f of a plus h, which is this quantity, negative 4h plus h squared, minus f of a, which was 0, all over, remember our ordered pair, right? F of negative 2 is 0, over h. So that gives me the limit as h approaches 0 of negative 4h plus h squared over h. Again, as we expect, that factor of h is going to factor itself out, so I have the limit as h approaches 0 of negative 4 plus h. Now this is something that I can absolutely plug 0 into to have a direct substitution, negative 4 plus 0, so I get negative 4 is the slope of my tangent line, which at that point, which is what I again expected given the basic derivatives rule, okay? So number 3 says to write the equation of the tangent line. Well, we just found out that the equation of the tangent line is negative 4, and we also have the point. So this was the point that we wanted to know the slope at that exact instant at negative 2, 0. So that's the point we're going to use. So calculus is done. This is algebra. You can use point slope. You can use y equals mx plus b. It does not matter. So I'm going to do y minus y1 is equal to the slope times x minus x sub 1. So I have y minus 0 is equal to my slope, negative 4, times x minus a negative 2. So I have y is equal to negative 4. A negative and a negative make a positive, so then I have a negative 4 times a positive 2 is negative 8. And that is the equation of my tangent line. The next question says to write the equation for the normal line. So the only thing you have to remember here is that the normal line is perpendicular to the tangent line at the point of tangency. So if I know that the slope of my tangent line is negative 4, then the slope of a line perpendicular to that would be the opposite reciprocal. So that means the slope of my normal line would have to be a positive opposite reciprocal 1/4. Now the tangent and normal line have to pass through the same point, negative 2, 0. So again, no calculus, all algebra. Y minus y sub 1 equals the slope times x minus x sub 1. So I have y minus 0 is equal to a positive 1/4 x minus a negative 2. So I have y is equal to 1/4 x. This goes to a positive. 1/4 times 2 is a positive 1/2. And that is the slope of my normal line.